So good morning. In this presentation, I'm going to focus on IanniX software features for graphic notation and performance, and compare them with the UPIC. I would like to start with a brief chronology by saying that both these tools participate in the process of democratization and openness, which led the first version of UPIC from a specific hardware version to a commodity version available for PC, till a prototype of software-only version in 2001, the UPICs. And actually the next year, in 2002, the development of IanniX started, thanks to Thierry Cauduit, Adrien Lefebvre and Gerard Pape, and the support of the French Minister of Culture. And so the idea was to develop an open source software, and also through collaborative development. The current developer is Guillaume Jacquemont, but the open source is on a GitHub platform, so users can contribute as well. Well, the big lack, in my opinion, was the missing of a proper and updated software documentation. That's why I decided to write it myself and to release it on the same platform, so this can be edited and updated by other users. So for giving a definition, I would say that IanniX is a graphic environment which is more general than a graphic sequencer, actually, for digital art. So it is, of course, a tool for notation and performance as well. We can build scores by combining three types of objects, so curves, which are trajectories in the score space, cursors, which are read heads that run along curves, and triggers, which are isolated events. So IanniX is based on the communication with other devices, so it is not self-sufficient. It needs other software and devices in order to work. So it sends and receives control messages through various protocols and interfaces, which are commonly used nowadays, such the Open Sound Control, the MIDI protocol, serial communication, and a couple of more. So we can say it's an evolution, an emulation of UPIC from the notation side, not from the synthesis side, because of course IanniX doesn't have an integrated engine like the UPIC. Then it adds new features, I will explain, and with the multimodal approach to input. So we don't have just one input mode for making scores, and it is addressed to multimedia, so not just for music actually and sound. So with the UPIC, we just had one input mode, which was the electromagnetic pen in the first versions, and then the GUI. And in IanniX, we have this mode as well, so we can write scores from the GUI, but we have a more advanced approach by coding, through coding. So IanniX is based on, IanniX scores are based on JavaScript. And also we can program scores from interfaces, so from the compatible protocols, so with other software. And this is very useful because user may have different skills and compositional approaches. So I would call this a multimodal input approach. Then with the UPIC, we just add arcs as objects, of course, with their attributes like envelopes and waveforms, etc. And while in IanniX we have three types of objects. So for controlling both continuous magnitudes as well as discrete values. And then we have, in IanniX we can have polytemporality, what has been called polytemporality, so we can add more tempi. I would like to show you, this is of course an emulation of UPIC in IanniX with a score of metastasis, a section. So in the UPIC approach, we just had one single timeline that reads, now I don't listen or anything. That reads curve values. But we can also set for each curve a different cursor, so a different tempo. So we change the space-time relation, we can change the speed of cursors and other attributes I will explain. Then we don't have to follow a linear reading path, but we can also set a curve. Now I'm using a very simple sound synthesis engine in Max MSP, but of course we can set whatever we want. Then we can control acceleration. We could do this with the UPIC by changing the speed, but in IanniX we can also set different acceleration patterns from presets. In this example, you see the first cursor with no acceleration and then a few examples of acceleration patterns. And the global duration, of course, it's the same. Also, we're not tied to time frequency representation or time amplitude representation, but we can imagine 3D scores. And even combine them with 2D. I would classify IanniX scores according to their functionality and the interaction mode with other devices. So the simplest kind of score is the control score, where we set it in advance before the performance, and then we just reproduce it. So we have just an output of messages. So in this specific case, we have each cursor and trigger that sends messages to other devices. In this case, from OSC. Then we have reactive scores, which are quite the opposite. So they actually work out of time, and the timing is set by an external device that sends command to IanniX. So this could be the example of listening scores. So we have a process, for example, an algorithmic process in MaxMSP, and we just want to visualize the score in IanniX. I'm going to close this. So in this case, we are giving some commands for generating triggers and set their color and time. So the position from max. Oh. So you don't see anything. So the alpha channel is actually the dynamics, so the amplitude of sound. Then vertical axis is actually could be a MIDI note, or in this case the pitch, just the pitch. And of course x-axis is time. So then we can also reproduce the score, so it's like a recording system. Then we have interactive scores, actually like UPIC. So we can imagine some user interaction, and in real time, of course, and then an output of messages for controlling other devices. So we have a bidirectional data flow, and with a motion capture device, we can draw the curves, the score actually. And set a gesture in order to reproduce them to return values related to such curves. And this can be in 3D, of course. Then we can generate scores through coding. So we can create a script with JavaScript, and then JavaScript can create the score once, so just at the beginning before the performance, or control it during the performance. In this case, if we take a look at the script, we are creating some triggers according to user variables, and we are setting a random position. I don't know if you can read it. So a random position or on the tree axis and a random color, for example. And then we are drawing, we are actually inserting a curve with random points and a cursor which runs on it, and it returns trigger values. So this is useful because we don't have to set manually the position for every trigger if you want some degree of randomness. And we can build a score with just a few lines of code. Last type is recursive score, where actually IanniX controls itself. So we can have 4 different significant cases of this. So the first case, when an object controls the sequencer. So, for example, this trigger can stop playback, or an object can control another object. And also here we have some randomness. So as this cursor gets here, if you can read the message we are sending, we are choosing the start of a random cursor. Another case would be a stable recursive system where actually an object controls another object, and they control each other's. So in this case, this cursor controls the radius of this circle and vice versa. So we have a stable system. Or, last example, we can also have self-oscillations and or chaotic behaviors. Okay, so we can use these features for many different applications. Of course, for creating a score through GUI, so let's say it manually, or for generating a score, and for, of course, the performance, so we can control audio or video parameters in real time. And in a specific case, we can use it to control spatialization, even 3D spatialization, of course, so we can set each cursor to control a sound source, for example, the movement of a sound source in a 3D spatialization system. We can use IanniX for controlling, for example, sound installations. So for controlling like Arduino or other boards, and also to react to sensors. Then, as you've seen, we can use IanniX to represent, just to simply represent the graphical data from outside, or even functions defined as equations. And finally, of course, we might want to represent the graphic data acoustically, so for sonification. If you take a look at the showcase on the IanniX website, you can see around 20 projects since 2007, which range from sound design to more musical concerts, to audiovisual performances and installations. I would like to go now more in deep in the interface. This is the main window, actually, which is divided in 4 parts. So we have this part, which is actually the representation of the score, so the visualization, and also we can edit the score from here. Then we have a toolbar on top. A main sequencer, I would call it main sequencer, because we can, as you see, we can set different cursors, so every cursor is actually a sequencer. And an inspector for controlling object attributes and system software configuration. So curves can actually have 4 different shapes. So can be a ramp, so a linear shape, can be a cubic Bezier curve, can be circular or elliptic, and can be parametric, so defined as an equation. And we can also imagine even very complex shapes. So this is just a single curve as a very complex equation in 3D. And of course, we can edit parameters in real time. So we get very complex shapes with just, let's say, a simple equation, or even more complex. Cursors have different attributes. They are used mainly for sending continuous messages over time, or for activating triggers. We have different attributes, so we can even change the texture to amplify the representational possibilities in IanniX, which are limited to these objects otherwise. Then we can set the speed or the duration for each cursor, the running pattern, so can be one run or a loop or a round trip. Acceleration, as I said, and we can, of course, map the score space to the parameter we want to control in the next stage. So we can do this mapping in IanniX. If we want to control a MIDI velocity or a MIDI note, for example, we can set this space to be from, I don't know, note 30 to note 80. Then we have triggers, which send normally just one message, so for single events. And we also have this specific duration attribute, which is useful for controlling, for example, MIDI notes. So we have actually 2 messages, one for note on, one for note off. And where is it? Each attribute, of course, can be used for storing the data we want to send to the next device. So in this example, I set the label attribute for MIDI velocity. So this is actually the numbers you're reading are MIDI velocities. Then the duration attributes are, of course, duration of notes. And here we have just a simple linear timeline. So, okay, so by changing this attribute, we change the duration of the note. So we can, IanniX mainly sends variables related to such objects, but we can also set fixed values in order to already set the syntax for controlling the other device. So these variables are related, of course, to transport, can be related to object IDs or groupings, and of course related to specific objects attributes, like the collision of a cursor with a curve or many other attributes. From the input side, instead, we can give comments for building a score from zero. So IanniX actually has its own scripting language, which is detailed in the documentation. So we have different commands we can send from interfaces, so from Open Sound Control, for example, or just write it on the script editor. So these commands are, of course, related to the main transport, to visualization of object, to the position and behavior and everything. So in the concert yesterday, this was the configuration I normally use. So a computer with IanniX and another computer with the audio engine. And these computers communicate bidirectionally or just in one direction in the case of control scores through Open Sound Control, so over a network. In the first piece, it was actually a control score for generating electronic sounds. So we had two timelines with cursors, which is basically a simple musical counterpoint. Cursors were used for trigger activation and also for setting the drone center frequency, because they weren't perfectly horizontal, actually, so they had some sort of oscillation. And this was actually set through GUI. Even all these triggers, so each object was positioned through the GUI, and each trigger actually was used as a container of attributes I needed for sound synthesis. So, for example, the vertical position was the fundamental frequency of a simple additive synthesis. Then the trigger duration was related to sound duration. I used groupings for setting different amplitudes, and label for setting, I don't know if you remember, there were some letters, and these were set for different timbres. So we had different sound synthesis timbres. Actually, I'm done. So if you have any questions. Of course, you can find more details on my website. There are a few papers regarding IanniX, or regarding the documentation or specific pieces.
Thank you very much, Julian Scordato. So I was wondering whether there are some questions from the audience. Yes, over there.
Okay. So my question is about the piece, your piece.
Yes.
You played it yesterday. So you explained that the piece was automatically generated in real time. Yeah.
Which one?
It's the constellation piece with the system.
It wasn't automatically generated, it was the opposite. So it was just every object was positioned manually.
Yes, but it's the sound is generated in real time.
Yes, of
during
course.
the concert.
Of
What's
course.
the purpose of that? Because there's no difference if you record everything in the video file.
Yeah, this was actually the most, let's say, the most maybe Xenakian piece, because I just wanted to have this kind of counterpoint, and so it was very simple. So it is, of course, can be reproduced. So it could be recorded, as you say. Yeah. Actually, that's true.
What's the purpose of using the real-time system for the playback?
There wasn't a purpose for this specific score. That's very true.
Okay. Okay.
It was just a compositional need.
Okay, we have a question over there.
Thank you very much. And in your process creator, how do you choose your timbre, your sound? Yeah.
How did I choose the timbres?
Yeah.
Well, actually, I mean, from a well, I don't get the question. So
we see how you organize your sound, but you don't say how you choose the sound, the library of your sound.
Okay.
That you organize.
Okay, so actually, the point was IanniX actually triggered very simple events. So as you see, very simple notes, let's call them notes. The complexity came next. So I wanted these sounds to interact to each other. That's why I use a feedback network system. So there, actually, this complexity was created not, of course, by a very simple additive synthesis, but with the interaction of simple sounds. I wanted to leave a strict relation with the visual part, of course, but also some degree of complexity. I couldn't get just with such simple events. So I hope I responded.
If I understand well, complexity is a value for you. It's not just something which exists in the same place as simplicity. What do you think about complexity, in fact, as aesthetically speaking?
Well, I would say that complexity comes from simple. I wanted to. My idea was to get to this, to a complexity which arrives from simplicity. So that's why I used IanniX actually. It came from simplicity, so it's a further process you get.
Okay, we have more questions.
Thank you, Julian. Impressive work. But as a composer, I would like to ask you, how, during the performance, how important is it for you to have the visuals at the same time? Is it what you would call visual music? Could this music, would you do a performance of Constellation, for example, without projecting onto the screen what's happening? As I told you yesterday, I had a problem with my eye, and I had to I had to keep my eyes closed because of this problem. And so I really listened to the music. I think probably in a way different than the rest of the audience who was doing a synesthetic more...
well, I wouldn't dare to give a definition of what kind of music is that, or visual music, or I do a visual... I don't know. But I just want to say I needed the score, so it helps me a lot for the performance, actually, the controlling of the performance.
In real time?
In real time, of course.
But you could use it off of your screen.
Yeah, but you give some more information to the listener, of course.
Yeah, but then we can have this conversation privately too, but let's assume that the brain is capable of 100%, okay? Yeah. And that this 100% then is being divided between the visual and the auditory. Mm-hmm. As a composer, are you comfortable with that? Are you comfortable with, let's say, half of the attention, the listener's attention?
Yeah, that's of course a risk. But, well, I tried both experiences. So to perform it in a large system without video, I'm not, of course, the video gets attention, but I don't know. I think I give more information, so I prefer this approach actually.
Okay, so we have a question over there. So the order is 1, 2, 3.
Thank you. Okay. My question is a very concrete one.
Yeah.
What is presently accessible user manual? You told it was an open software. No.
Yes. So
yes.
It's multi-platform,
okay.
And you can access it from the website.
Ah, okay.
So it's available.
And documentation too?
Yes, of course.
Okay.
Of course.
Okay, thank you.
In English. Documentation in English.
So we have another question coming up from Ludger Brummer.
It's not really a question, it's a response to this discussion of visual music, because I thought as well a lot about this, and I am a little bit on the side of your reply. You provide additional information. You can, as you did, always close your eyes if you don't want them. So you have the choice. That's one thing. The second for me is not everyone has access to, let's say, complex music. Not every listener has appreciation or access to analyzing, understanding, enjoying complex music. And sometimes it's a way to build a bridge to this kind of listener who usually would not listen to this kind of music. This is another thing we should not neglect, because we are in a very, let's say, contemporary music is not in a very easy situation this time, and I think we should use the tools we have to create bridges to other audiences. And despite of that, this is part of the EU program where this is this interfaces where this is taking place, and it's a reason that the EU. I don't want to be a politician, but I think that it's a significant. You can read the problems in certain aspects of their program, and there is creating new audiences. So communication, opening up, putting down borders of aesthetics, borders of groups. This is one challenge we have in art today.
So is there a comment on that comment?
Just a quick comment on your comment, which was a comment on my comment. I agree. I mean, in principle, I agree. But I think there's also an artistic responsibility for what's being projected. You have to own that as much as you own the music. And we're composers, we're musicians. And the visual aspect, it seems to me that then you sort of delegate this to the machine to do it. And I understand that it's a bridge and an open hand, a welcoming hand to new audiences, or even to ourselves. It's a way to penetrate the music in a different way. But it's the authorship of this. It's the way you author your compositions. Suddenly, this is being generated by something that, yes, you're controlling from a program point of view, but from a visual point of view, you know, it's a little bit fuzzy about who owns the visuals.
Yeah, this is interesting because the second piece was actually, as you have seen, a score by Robert Moran. So in that piece, I wanted just to read the score differently. So it was an instrumental score for ensemble, and I just wanted to read it in a different way. So I actually, we could say I didn't write anything. It was just about a process of reading, and that interests me.
Yes, to go in the same way. I have to confess, yesterday evening I closed my eyes several times to hear, to try to hear, but unfortunately I have just 2 ears, so I can't listen all of the complexity of the music. So I imagine, yesterday evening, I imagined that maybe your music, this kind of music is for, not for 2 ears, but for 100 ears. Unfortunately, it's difficult to griff it. To make prothesis. So that's my question about complexity in music. It's always, when you have a great un bruit blanc. Un bruit blanc. Yes, a great noise. It's really difficult to hear the evolutions inside of the gray noise.
I mean, from your imagination?
For me, not for my hairs and my breath.
So the question is? I don't.
Okay, so now, if you may, I'd also like to raise a question. So, okay. I consider IanniX as an interface with which you can potentially also interact with things or objects which are not necessarily musical in a conventional way. So now you showed us pictures presenting those microelectronics. I saw some sensor inputs, for instance. So I was wondering whether you already experimented with microelectronics on the output side, like robotics, motor, something like that.
Actually, Yannick's team did this in a project, and you can see it from the showcase. There's a project which uses Yannick's for controlling the axis of the automation of a robot. Yes, I used it from the input side for audiovisual installation, and it was, of course, the public was very different.
Okay, yeah, so thank you. So I consider this also a very important point, because at this stage also a field opens up for media artists who would like to make things communicate, like different objects, machinery, motor, stuff like that. So I was once seeing a piece by Tempo Reale in Firenze, for instance, who worked exclusively with everyday objects which they drove by the usage of motors, for instance. So there was no sound synthesis going on there, neither was there any part of a conventional musical instrument. So here we really have a field where we have an interface with which you can interact with many different things. So just to highlight how open the field actually is. Yes. So thank you very much, Julian Scordato. This was very interesting. Thank you.